do what I think is one of the last problems, if not the last problem, and it's alcohol and gender. Cool. Alcohol and gender. So here we have our contingency table. There you go. Here is the grand total. Which also uses the symbol N. So let's write our pair of a hypothesis. Our researcher wishes to determine whether there is a relationship between gender of an individual and the amount of alcohol consumed. So usually when I teach this to face-to-face class, I'll go, yeah, there's a difference. Let's see what the data tells us. No. The amount of alcohol is independent of gender. Alternative, the amount of alcohol is dependent of gender. Is dependent of gender? Yeah. Cool. So we need to find the critical value. We need our alpha, which I'm gonna have to change. Let's change it to 0.01. Alpha is gonna be 0.01. And the reason I have to change that is because our table, the textbook doesn't have the 0.10. I don't know why. It was probably too expensive to print another column for 0.10, but whatever. Alpha 0.01. My degrees of freedom are going to be the number of rows minus 1. Oops. Minus 1 columns. Minus 1. So this is one row. This is the second row. 2 minus 1. The columns are going to be 1, 2, and 3. So 3 minus 1. So don't count the total columns when you're doing your degrees of freedom. That's a mistake that I see pretty often, unfortunately. So just 2. Chi-square table. Remember, we're always looking at right tail. So we're always looking at this row for our alpha. It's right tail because our chi-square test is, well, the chi-square distribution is skewed. So we're always looking at this tail when we're doing the hypothesis test. Our degrees of freedom for this problem was 2. And our alpha was 0.01. So our critical value is this one. So if there's not a difference at that alpha, it could be we just need to collect more data. Just saying. So chi-square crit is 9.21. Now we need to find, I wish I could make this fit into a single shot. And now we need to find the expected value. So I'm going to use the cells total observed for the observed values, and then the cells total divided by the grand total. Write it here, grand total. Okay, so remember the expecteds are going to be row, comma, column. So for this cell, I'm doing row 1, column 1. So it would be row 1, column 1 divided by the grand total. 27 times 23 over the grand total, which is 68. I'm going to go down this time. So it would be here, row 2, column 1. So it would be row 2, column 1, grand total. 41 27, 68. It doesn't really matter which way you go, as long as you know where you're going. Sounds very inspirational. Okay, so row 1, column 2. So row 1. Row 1, column 2. And then the grand total. 27, 25, 68. The next one would be, let's change colors again. Let's go with green. Column 2 over row 2 over the grand total. So 41 times 25 over 68. Let's use blue. So row 1, column 3. Row 1, column 3. 27 times 20 over 68. When I calculate that, I should have been calculating this a while ago. 7.94. Row 2, column 3. So row 2, column 3. 41 times 20, 68. I just realized this should be an 8. When I calculate that, it is 12.06. Here is going to be, first of all, purple, 9.93. Equal, here is 15.07. 9.13. And finally 13.87. So that's it. This is my expected values. Expected. And it's also right there. So it's not a surprise that what we're looking for is the expected values. This is also a type of contingency table. Okay, so we're going to put our expected values into our E column. So 9.13, 9.93, 7.94, 13.87, 15.07, and 12.06. Let me check my table. Yep, that looks pretty good. So now I want the observed values, and that's actually from the first contingency table. So these are the observed values. And I'm just going to go the same way. I'm going to go this way. 10, 9, 8. Let's change the color. 10, 9, 8, 13. Let's do this. 16, 12. I know for some of you, the table might be like a big waste of time. It does make it easier for me to grade if I was grading a paper and pencil test. So if you prefer to just write like 10 minus 9.3, 9.13 over the E, that's okay too. For now it is okay, at least. Now let's do observed minus expected. So this is going to be 0.87. Negative 0.93, 0.06, negative 0.87, 0.83, again, negative 0.06. Now I need to square this column. So 0.75, 0.86, 0.0036, 0.75, 0.86, 0.0036. So for the next column, what I need to do is divide the previous column by E again. So 0.082, 0.08, 0.086, 0.00045, 0.054, 0.057, 0.00029. Remember, the next step is always to sum. We're doing this part. We already did everything else in the formula. So chi-square obtained is going to be 0.283. So next I need to make my decision. Remember, my chi-square is always positive, starts at 0, and then it increases. My chi-square critical was 9.21. I was going to say 29, so I'm glad I looked. And my chi-square obtained would be over here. Chi-square obtained 0.283. So because it's not in the rejection region, I do not reject the null hypothesis. So let's go to my pair of hypotheses. I do not reject it, so I'm going to put a check here, cross here. So there's evidence to support the null that the amount of alcohol is independent of gender, at least in our sample. I know people have, this is the part in the class where people give me a lot of anecdotes that I don't really want to hear. Okay, so let's go over the technology. When we do this in Jamovi, first it's going to give us the contingency table, and we're not really interested in this one because we have this table usually when we're trying to do like a problem by hand. If we just have a data set, we do need this table for sure. We need to look at it. We know our sample size is here, and it's going to be that. Really, the table that we want to look at is this one that has the chi-square. So value is our chi-square obtained. This is our degrees of freedom. This is our p-value, which is really big, by the way. And this is our sample size. So this should be the same. I point that out because I had a little typo here, so I'm going to show you how to fill that out. So the first thing you need to say is the type of test. So we did a chi-square test of association. It has other names like chi-square test of independence. Because we have two variables, gender and alcohol, we can say it's a two-way chi-square. That's also appropriate. I just go with association because that's what Jamovi calls it. Alpha was 0.01. We didn't do this. So we are going to compare a p-value, which is 0.964 from here, to our alpha, which is 0.01, and it is way bigger than our alpha. So we do not reject the null hypothesis. Do not reject. Whenever we do not reject the null hypothesis, we all know that there was no statistically significant evidence. And that would be the next sentence. There was no statistically significant evidence that the alcohol is independent of gender. Or you can say that variable A is independent of variable B. And then you just fill out what A and B is depending on the problem. Here I use the Warren nullity table. Basically just tell me how to write it. No statistically significant evidence. That's it. Here I have, Here I have the symbol for chi-square, my degrees of freedom. My sample size is 68, so here it should be 68. This is our chi-square obtained from here. Then I have the p-value, which is equal to this. And don't forget to italicize the p. I always forget.